Hello! Welcome to Squid Essays. Inking your academic pen. My name is Julie and I will be your instructor as we read through Plate Tectonics Essay. The article source is embedded in the video description below. Feel free to read along. Please note that you can get a custom, plagiarism-free essay for as little as $10 a page at Squid Essays. The link is in the description. Assess the strength of the relationship between tectonic processes and major landforms on the Earth unregistered trademark S surface. Tectonic processes have been responsible for the major landforms across the Earth unregistered trademark S surface. These processes are controlled by the convection currents rising from the Earth unregistered trademark S mantle. Firstly, one place where tectonic activity occurs is at oceanic to oceanic constructive plate boundaries. Here two plates diverge or move away from each other, pushed apart by huge convection currents in the Earth unregistered trademark S mantle. These convection currents are initiated by heat energy produced from radioactive decay in the Earth unregistered trademark S core. As the convection currents move the plates away from each other, there is a weaker zone in the crust and an increase in heat near the surface. The hotter, expanded crust forms a ridge. Magma rises up from the mantle in the gap. The lava cools, solidifies and forms a chain of volcanic mountains thousands of miles long down the middle of the oceanic Atlantic. There are transform faults at right angles to the ridge. The movement of these faults causes rift valleys to occur. Examples of these landforms created by constructive plate margins are the Mid-Atlantic Ridge, MIR, and the Great African Rift Valley, GARV. The MIR is the result of the North American Plate and Eurasian Plate diverging in the middle of the Atlantic Ocean. Here, volcanic islands such as Iceland, the Canary Islands and Ascension Island have been created by the rising magma from the mantle. The GARV is an example of where the crust has dropped down between parallel faults to form rift valleys. As the crust subducts into the mantle, it melts, causing igneous activity below, magma to rise, and therefore volcanoes erupt on the surface as a result. Evidence of this volcanic activity is shown by Mount Kenya and Mount Kilimanjaro. The lava here has a low viscosity, it's very hot, 1200 C, and has a low silica content. An example of where landforms have been created at a different plate boundary, a destructive plate margin, is where two plates, the Nazca Plate, an oceanic plate, and the South American Plate, a continental plate, converge. Here, two plates meet and the denser oceanic lithosphere of the Nazca Plate is forced down under the more buoyant continental lithosphere of the South American Plate, descending at an angle into the mantle in a process called subduction. This is marked on the ocean surface by the presence of the Peru-Chile Trench. The friction between the plates prevents the subducting oceanic plate from sliding smoothly. As it descends, it drags against the overlying plate, causing both fracture and deform. This results in frequent shallow focus earthquakes. The subduction of the Nazca Plate under southern Chile produced the largest earthquake ever recorded, with a magnitude of 9.5 in 1960. Volcanoes are also created here as one plate subducts and partially melts. The magma rises up through fissures and can reach the surface. The type of lava here is andesitic, very high in silica and not very hot, resulting in a composite volcano being formed out of layers of ash and lava. The Cascade Mountain Range is an example of where a destructive plate boundary has caused the Juan de Fuca Plate to subduct under the North American Plate. This resulted in 15 composite volcanoes being formed, one of them, Mount St. Helens. Similar to the Peru-Chile region, the Japanese islands are situated in a subduction zone. In the northwestern margin of the Pacific Oceans, the Pacific Plate and Philippine Plate converge. On the Pacific side, trenches run parallel to these islands. As one plate subducts beneath the other, it heats up and melted magmas rise towards the surface. These Japanese island arcs extend 3,000 kilometers and magma produced under them form felsic plutonic rocks, granite, some of which erupts on the surface to make volcanoes. Large-scale formation of granites develops the crust of island arc. On the other hand, some tectonic activity DOEs and unregistered trademark T produce any landform. An example is at the San Andreas Fault. Although both plates are moving in a northwesterly direction, the Pacific Plate is moving faster than the North American Plate, 7 centimeters a year faster, so the relative movement of the North American plate is to the southeast. The Pacific plate is being moved northwest due to the seafloor spreading from the Pacific coast rise in the Gulf of California. The North American plate is being pushed west and north due to seafloor spreading of the Mid-Atlantic Ridge. Movement is sporadic and jerky. Frictional forces lock the blocks of lithosphere together for years at a time. When frictional forces are overcome, the plates slip and shallow focus earthquakes are generated. Similarly, landforms can be produced without the source of tectonic activity. The Hawaiian Islands are not connected with any plate boundary. The volcanic area is caused by a localized hotspot beneath the Pacific plate. A concentration of radioactive elements inside the mantle may cause such a hotspot to develop. From this, a plume of magma rises to eat into the plate above the hotspot. The hotspot is stationary, so as the Pacific plate moves over it, lines of basaltic shield volcanoes are created. These can be eroded to have flat tops called geos. In Hawaii, the main island is closest to the hotspot and so it is the most volcanically active. However, as the Pacific plate moves northwest at 10 centimeters a year, a new island, Loihi, will form as the submarine volcano builds up to sea level. Finally, collision plate boundaries when continental and oceanic plates collide. The thinner and more dense oceanic plate is overridden by the thicker and less dense continental plate. The oceanic plate is forced on into the mantle by a process called subduction. As the oceanic plate descends, it is forced into higher temperature environments. At 100 miles deep, the subducting plate begins to melt. The partial melting produces magma chambers above the subducting oceanic plate. The magma ascends through the overlying materials, melting and fracturing its way up. If the magma rises to the surface without solidifying, it will break through in the form of a volcanic eruption. The Himalayan mountains are an example of where the Indian continental plate has been put under extreme pressure as it collides with the Eurasian plate, forcing the edges of the plates upwards into a series of folds, as one subducts beneath the other. In conclusion, the strength of the relationship between tectonic processes and major landforms on Earth can be described as strong. There is a clear correlation between the events that occur at constructive, destructive and collision plate boundaries and the landforms produced consequently. Although there are situations where the two are not linked, ultimately the characteristics of the landform will have been influenced by some soft of tectonic movement. For example, the chains of Hawaiian hotspot islands are in this shape due to the northward movement of the Pacific plate. Thank you for taking your time to listen to me. I hope you enjoyed learning about plate tectonics essay as much as I did. Kindly remember that you can get a custom, plagiarism-free essay at Squid Essays for as little as $10. The link is in the description. See you next time.